This tutorial covers the input load elevation command and does not cover the processing of an elevation using point clouds and LSS 3D vision. In the test data folder there is a folder called example elevation data, and it's the load file within that folder which we will be using during this tutorial. I'm going to create a new survey. I'm going to browse for the load file within that example elevation data folder, and I select input load. But before I load the file, I'm just going to show you how that elevation file will be structured. The surveyor is set up on station STN1 and he's referencing STN2. The survey for the elevation can include topographical detail as well as the elevation data itself. And before the elevation begins, there are a couple of topographical survey readings, the first of which is coded BS, and then BS is completed there. This reserved code, -EL, tells LSS that all of the points that follow can be treated as elevation points. That is until either the end of the file or until a new instrument setup is reached. If there is another instrument setup, then the -EL will need to be used again to define the first point on that elevation. We will present the file to LSS, go through the normal load procedure, it now tells us that elevation data exists in the load file and may now be extracted. What's happened in the background is that the points, including the stations, have been loaded into the survey, and we can use those as baseline points. We're now looking straight down onto the top of all of that elevation data. We can choose to create a new LSS load file, which will then be loaded into a new elevation survey, or we can send the data straight out to an AutoCAD DXF file. Well, I will choose to process this data into a new LSS survey. I'm going to call this LEV1, and I will then be asked to define the baseline of that elevation. Imagine looking at a building. The X is the axis across the front of the building, the Y-axis is the axis going up the building, and therefore the Z-axis can either be a choice of 0 for everything, it can be the distance of the point in front of or behind the building facade or the baseline that we define, or in fact that third dimension could be the altitude of the point on that elevation. The perpendicular distance option will be useful if you are comparing two elevations and you're wanting to determine whether there has been movement between the two surveys. The option to include terrain features will allow us to include on the elevation any points which exist within the topographical survey, such as steps going up to a door, or a fence line or a gate in front of the building. I'm going to select the perpendicular distance to the reference line. We're now presented with the menu to define the start and end of the elevation baseline. The start will always define the left-hand side of the elevation as it will be drawn. And because we're in snap-on observation mode, it's now only finding those 2 points that were loaded at the beginning of the load file, the BS featured points. And because they exist, we can use those as the baseline of the elevation. If you don't have points, then you can select using the mouse and you can choose wherever you want the baseline to start and end. The default width is 5 meters. We can reduce it by entering a new value, or we can actually locate the width. And what we're going to do here is make sure that all of the points on the elevation are included in that corridor that we've defined. We can also extend the corridor out beyond the end of the points that we've selected at both ends. We can also include intersections with that corridor, and the situation would arise here where, as that line crosses the boundary for the elevation, it could then drop a point onto the reference line. We select OK, and if the data contained the next elevation, we could now choose to process another one, define a new baseline, and then create the next elevation. If you want a building to be unwrapped, so to speak, into a single panoramic view, then make sure that you're always working left to right from outside, and then each subsequent elevation will be tacked on to the end of the previous one. Save and load. There we will see the elevation drawn. These blue lines are contours, and if you look in the lower right hand corner you will see the distance in front of or behind the baseline that these points represent. You can obviously edit this survey. There is no reference here now to any original coordinates. For example, this lower left hand corner will be at, in this case, 0 east and 100 north.